Hello everyone, welcome to gradeup. Yes, I can see some of you have already come live with us. So it's 6 p.m. again and we are live with the subject of strength of materials for you. Okay, this is the plan going, the Gearup JE plan for the mechanical course for the RRB and SSC. Okay, so I can see some of you. Yes. Yes. Hello everyone. Yes. Okay, great. So first of all, this is the schedule. This is the schedule. Yes. Hello everyone. This is the schedule for the subject of strength of materials. There will be total 4 classes. Okay. By somehow it is written 4, 5, but do not get into that. You just see the dates. The classes will be on 18th, 20th, 25th and 27th. Okay. Yes, civilians can also follow this. Yes, absolutely. Okay. So due to the Holi festival, so there will be a gap from 20th to 25th, and on 25th there will be third class and the last class will be on 27th. Okay. For the which all topics we will be covering on that. Gate series was very helpful. So okay, great. So these are the schedules for the subject of strength of materials, and when we come to the syllabus that is given in the SSC and RRB JE, the syllabus is as like this. I am speaking in English only. Okay, so this is the syllabus which has been officially mentioned in the official notification syllabus given by SSC and RRB JE. Okay, timings will be 6 p.m. only. Okay, timings will be 6 p.m. only. Don't worry about it. So this is the syllabus. This is just the basic syllabus that has been mentioned. We will be going into a 5 classes are enough. 5 classes are for the Gearup JE'19 plan. Okay, so for the information of you all, we will be soon launching a CBT 2 course, the CBT 2 paid course for mechanical engineering. Okay, that will be available for purchase soon after the Holi festival. Okay, most probably by the end of this month or the starting of the April month, that paid course will be available to you. Okay, in that we will be covering entire syllabus. Okay, that on that we will be covering the entire syllabus of mechanical engineering. Okay, yes. The timing of online class, this Gearup JE class, the Gearup JE'19 class, that timings for that it is already all of you know, it is 6 p.m. Okay, 6 p.m. The timings are 6 p.m. Okay, so those all who have joined us right now, Vikas Kumar, Bala Murugan, Indian Traveling Fastest News, Nikhil R, Rahul Bharadwaj, to all of you once again good evening and welcome to this session. And class duration will be around, maximum duration will be around 1.5 hours. Okay, 90 minutes you can say, 1.5 hours. Sir, tell according previous exam questions. Yes, we will be doing that previous year questions in this session. We will see some of the questions. Okay, so first of all, we see this syllabus. Okay, stress strain has been mentioned. Okay, stress strain has been mentioned. Some of you have also joined us again. That's great. The number of viewers are increasing. It's absolutely fine. Okay, daily classes. The classes will not be daily. The schedule has been given to you. There will be 4 classes of SOM, 18th, 20th, 25th and 27th. Okay, so now moving on to the syllabus, stress strain has been mentioned. Okay, stress strain diagram has been mentioned. So if I talk about the stress strain diagram, okay, in this session we will be looking upon the syllabus, the greater details of the syllabus, that only this much syllabus has been mentioned, but what else or what deeper from these topics can come. Okay. The continuous classes will be most probably in the end of this month, in the last week, that is after the Holi, or after or in the month of starting of April. Okay, that will be a paid course, CBT2 paid course. CBT2 paid course for mechanical. Okay, CBT2 paid course for mechanical. 22nd March there will not be a class. Okay, 27th March there will not be a class. Mechanical, that will be either from 25th of March or 1st of April. That course will be live either on these two dates. Okay, 25th of March and 1st of April. In this live class, in this paid course, the timings will be variable. You will be shared a full schedule of those classes, and accordingly you can see the timings. Okay, for this live session, the Gearup JE, the YouTube series that we are running up, the timings are 6 p.m. Okay, gate classes will also start very soon. Fees for this will be, something around 8K. Something around 8K. The classes will be something around 8K. Okay, so that's the discussion about that course that we are starting soon. So now coming back to this session, thermodynamics class has been done in this one. The thermodynamics class has been done in this session, in this Gearup JE'19 plan. If you have missed that, you can take them. Okay, for civil also we are planning. For civil also we will be bringing the course very soon. Okay, so now stress strain diagram, we will see the concept of the stress strain diagram. We will analyze each and every point in that stress strain diagram in a greater detail, and then there are some terms that are related, like the toughness, resilience. Okay, then the moduluses of these, that is toughness, modulus of resilience. Okay, so and then there comes the concept of strain energy. Okay, strain energy, all those concepts come from this stress strain diagram. Okay, so we will be having a greater look into this, that is in the stress strain diagram. Then comes the important topic of factor of safety. Okay, factor of safety is also one of the important topics when we talk about the strength of materials. Okay, then it is written in that thermal stress. Okay, so in the thermal stress there will be all the cases that we will be discussing. This is not what I am telling you which we are going to cover. Okay, this is, I am telling you about the greater details, that we are going to cover, or that is basically the syllabus, which if you are preparing of your own, if you want to prepare of your own, that which are the things which you want to learn, or which you want to cover from the exam point of view of SSC and RRB JE, okay, from the subject of strength of materials. Okay, so in the thermal stress we will be taking the different conditions, like the conditions of the completely constrained case, partially constrained case, the free expansion case, all those cases we will be taking in the thermal stress. Then the strain energy, proof resilience, modulus of resilience, that as I have already discussed. Okay, then about the SFD and BMD if we talk, okay, there are different cases of SFD and BMD that we will be that are important. Okay, like there are different types of beams, the cantilever beams, the simply supported beams. Okay, we will see what are the indeterminate data and determinate beams. Okay, so that we will be considering in this topic of SFD and BMD. Then talking about the torsion. Okay, torsion, the twisting, that is also important. That the class has just started right now. Okay, don't worry, you are not late. We have just gone 5 to 6 minutes into this class. Okay, so you are not late. Then in the torsion we will be covering, if I talk about torsion, torsion is an important case. We will see the torsion, the shafts that are in series and parallel, that all we will be discussing in this. Okay, or that is basically, I should say, that is the part of the syllabus. Okay, then it is mentioned in the syllabus about the thin cylinder shells. Okay, thin cylinder shells, or you might have also learned this topic by the name of thin pressure vessels. So these are the important topics that are mentioned, but the other topics which are important, which are not mentioned in the syllabus, are like the bending moment or the bending stress. Okay, like the torsion we have discussed, so the bending stress is also important. Then one topic comes out here, that is of deflection. Okay, the questions have in the past come from these topics also, that is the bending stress, the deflection. And one topic is more that is there from which the questions have come, that is either you can say the column buckling, or you might have also learned that topic by the name of column and struts. So these are all the topics which are important or which are really you need to cover from the subject of strength of materials. Okay, strength of materials, mechanics of solids, mechanics of materials, by whichever name you have read this subject. Okay, so this you can cover from the subject of strength of materials. So in these 4 classes that we have for you in this Gearup JE plan for the strength of materials, there are 4 classes. The first class is today, that is the introduction class. Okay, this is the syllabus, that is the syllabus discussion, the greater syllabus discussion. I have shown you that these are all the important topics that you need to cover. Then we will be in this today's session only, we will be looking some of the previous year problems to gauge the level of the examination, that what is the level of this examination, on what line you have to prepare. Okay, so that we will be seeing today. Then the second class will be of the topic of stress, strain and elastic constant. Now basically we will be starting with the stress, strain, comparing them, okay, making their relation using the elastic constants. We will see what are the elastic constants and all. The second class will be on that. Then the third class of strength of materials, that will be live on 25th of March. That will be on this topic of SFD and BMD. This is an important topic, so we will be looking into the greater detail of this topic on the third class, that is on 25th. That is the last class, that is on 27th. Okay. On 27th, the last class of the strength of materials in this Gearup JE'19 plan, we will be discussing the important MCQs. Okay, important MCQs regarding from the subject of strength of material, so that we can have some kind of practice. Okay, so that is basically the plan for this Gearup JE'19 plan, subject of strength of materials. So today I have shown you the syllabus. Now I will be showing you around 15 plus questions, the previous year questions which have come in the exams or in the actual exams of RRB and SSC JE in the previous years, and then you have to do just look into those problems. Okay, try to identify the topic, give the answer and gauge the level of the examination. Okay, so now moving on with the first question. This says there is a very little difference. Okay, there is a very little difference in the syllabus of, okay, give the answer fast, then I will be moving on to the next questions. Okay, I have 15 plus questions. I don't want to take lot of time in this session. Just take the give me the answer for this one fast. Yes, I have started getting the answers. Plastic, option D. Yes, yes, elasticity, modulus of elasticity is 0. The material is said to be what? Rigid. Some of you are saying rigid, some of you are saying plastic. Okay. Yes, the answer for this one is the answer for this one. The modulus of elasticity is 0. The modulus of elasticity is 0. The material is said to be rigid, plastic, flexible or plastic. Okay. Yes, most of you are correct. The answer for this one is rigid. That is option A. Okay, rigid means that the plastic is not able to deform. Okay, the plastic is not able to deform, and in that case the material or the body is said to be a rigid body, and the modulus of elasticity in that case is 0. So the correct answer for this one is option A. Yes, option A is correct for this one. Okay, yes, you all are correct. Yes. Now the unit of elastic modulus is the same as those of. Now we are into the second question, and now it's my request to all of you that please for the questions which I am giving you, do one thing. For the questions which I am giving you, you answer while writing. Just first write the question number, that is 1 or 2, and then give your answers. Okay. Okay. So that will be easier for me as well and for you as well, that I will be able to see that for which questions you are talking about. Okay. So it's my request that you just write the question number and then your option in front of it. Okay, do that, please. Please write the question number first and then give me the answer. The unit of elastic modulus is same as those of elastic modulus. Modulus of elasticity, you can say. Modulus of elasticity or elastic modulus, that is defined by E, that is stress upon strain. Okay, this is stress and this is strain. Okay, and you all know that strain is simply the change in length upon original length. So this does not have any unit, this is unitless. So E and stress have the same units. E and stress have the same units. So that means your option A is correct. Okay, option A is correct because stress and elastic modulus has the same unit. Then shear modulus, that is G. G is again tau by gamma. That is the shear stress upon shear strain. Okay, this is also shear strain, that is the angle that we measure, the angular deformation, so that is also unitless, and this also has the same unit as of this. So this is also stress, G is the shear modulus, the same unit. And the unit is Newton per meter square also, Newton per mm square also, whatever you can say. Okay. So this is this unit, that is, this is the unit of pressure as well. This is the unit of pressure as well. So all these terms, that is the stress, shear modulus, elastic modulus, pressure, all have the same units. So the correct answer for this one is absolutely all of you are right, that is option A. Okay, now moving on to the next problem. See this one. This says in the case of pure bending, the beam will bend into an arc of A. In the case of pure bending, please read the question first and then give me the answer. We are talking about the pure bending case. Okay, pure bending case. Yes, 2 answer is absolutely correct. That is, you all have given in the answer 2, A for 2. Yes, that's absolutely correct. Yes. Now in the case of pure bending we are talking. The case of pure bending, the beam will bend into an arc of. In the case of pure bending, 3 answers have come in the form, only 1 answer I have got, that is, yes, now I am getting the answer A and B. I have also get the answer as B. Most of you are giving me the answer as A. So in the case of pure bending, the beam will bend into an arc of A. Course complete करवाएंगे in the paid course. Yes, complete course करवाएंगे paid course में. Okay, not in the free YouTube series. That is already the plan that we have discussed with you. In the case of pure bending, the beam will bend into an arc of A, circle, parabola, ellipse or hyperbola. Which is the answer? Yes, there is nothing to be explained in this. See, from the bending equation, we know that m by I is equal to sigma b by y equal to E by R. Okay. Now, this E will, this E is the elastic modulus, this R is the radius of curvature of the circular arc. And if we are talking about the pure bending, that means this m is constant. Okay. So, taking these 2 cases, these 2 together, what we get? M by I is equal to E by R, okay, E by R, or we can also write this as R equal to EI by M, R is equal to EI by M, and when this is constant, okay, the material E is constant, the I is also constant due to the means the geometrical property. And then this m is also constant. This m is also constant. So this r will be a constant. And when the R is a constant, that means it's a circular arc. It will form a circular arc. Okay, not a parabolic arc. Parabolic arc is formed when there is the case of only bending, not pure bending. Pure bending means that M is a constant. This is the case of a pure bending, that is M is constant. Okay. Either it is written that it's a case of pure bending or it is written that M is a constant. That means one and the same thing. Okay, so the answer for this one is option number A. Okay, those all who were saying the answer as B, please take a look into that. B is not the answer. A is the correct answer for this one. Okay, A is the correct answer for this one. Okay, case of pure bending. Please note that word pure bending it is written. Okay, so now see the next question. What is a prismatic beam? It is talking about a prismatic beam. What is a prismatic beam? A prismatic beam has uniform. What does a prismatic beam has uniform? Okay. Prismatic beam has a uniform. Option like circular arc. What was written in that? Into an arc of a circle. I don't know what is the problem you are facing. That is the right answer for that one. Yes. Radhe Shyam Prajapat, what you didn't understand? Please tell me. Just take the bending equation. Okay, first and third terms you take, that is M by I equal to E by R. And in the case of pure bending, the M will be constant, so R will be constant. And if the radius of curvature of the arc is constant, that means it's a circular arc. Okay, that is what I need to tell you. Yeah, fourth one. Prismatic beam has a uniform. Some of you are saying D. Most of you are saying D. Some of you are saying B, A, C. I can get a mixed number of answers. But what is a prismatic beam? A prismatic beam means that is a beam which has a same cross section. Okay, we are not talking about the width here. Okay, the width can vary. If the width can vary, but the area of cross section must be same. Okay, this area of cross section must be same throughout the length of the beam. Throughout the length of beam, this area of cross section must be same. Okay, so the right answer for this one is absolutely option number D. That is, a prismatic beam has uniform cross section or the area of cross section. I will be constant. I is constant because I depends upon the cross section. Okay, for a circular cross section, if you talk about, the I is different, means the I is constant for that case. If you take a square cross section, the I is constant. For a rectangular cross section, the I is constant. For the I section, the triangular section, for all those, the I, that is the value of I is constant. Okay, that is the moment of inertia or the second moment of area, you can say. Okay, that is constant. So that's why I is constant, E is constant, that is the material property. If it's the same material, it is made of same material, the homogeneous material that has the same E. And I depends upon the cross section or the, yes, on the cross section only, yes, on the cross section. And if it is a case of a pure bending, then M will also be constant. Okay, for the say, yes. So that's why that R become constant and it's a case of a circular arc. Okay, the fourth question, I think nobody has any problem in this. Cross section. Paid course for civil will come soon. Okay, don't worry about it. For the paid course of mechanical, it will be around 8,000 rupees. Okay, only CBT 2. And if you are interested in purchasing the full course CBT 1 plus CBT 2, that will be around 12,000. Okay, that is the early bird offer we are giving you. Yes, early bird offer, that means the prices will be at this discounted price for very less period of time. If you want to purchase it, if you are really interested in cracking the examination, in fulfilling your dream of becoming a junior engineer in the railways, so that's a golden opportunity that has come your way after 3 years, and that you can purchase the course as soon as it is live. Okay, give me the answer for this one. A beam is fixed at one end, free at the other end. The load acts in the center. The maximum bending moment will occur at which? First of all, you have to identify the case, which case of beam it is. Either it is a simply supported beam, or it's a cantilever beam, or any other kind of beam. Okay, give me the answer for this one. Most of you are giving the answer as C. That's absolutely fine. We will consider it in a later part. Okay, after some time. First of all, I am asking about this thing, that which kind of beam it is. Okay, someone has joined us late. Sandeep, very good evening to you. Time of class. Time of class will be for this Gearup JE session is 6 p.m. And if you are asking for the paid course, the class timings will be variable. Okay, there will be around 1 or 2 classes every day of around 90 minutes duration of each class. Okay, so first of all, give me the answer that what I am asking, that which case of beam it is. Is it a cantilever beam, or is it a simply supported beam, or any other kind of beam? That is a beam fixed at one end, free at the other end. Cantilever, absolutely right. Absolutely right. I have got 2 responses, 3, 4 responses. Absolutely right. Now today you are showing us the interest in these classes, and that's absolutely great. Absolutely great. That is helpful for you as well. Okay. So yes, this is the case of a cantilever beam. Yes, absolutely right. This is the case of a cantilever beam. So in the case of a cantilever beam, it says that fixed at this end, free at this end, and then it says the load is applied at the center. Okay, suppose this is the beam of length L, the load is applied at this point. Okay. Yes. Then if you see this much part of the beam, there is no load acting on this, so there will not be any shear force and no bending moment. So in this case, there will be no shear force and no bending moment in this part. Okay, only the shear force and bending. In this section about, if I talk about, there will not be any shear force and not any bending moment in this much section. Okay, and in this much section, there will be a shear stress and there will be a shear force. Okay, so if you take a section, any section XX from this side, and if you consider, okay, if you consider it from this length, that is this one, at a section X. So what will be the shear stress? The shear stress will be shear force, or the shear stress, shear force will be basically W into X. Okay, W into X, that will be the shear force. And what will be the bending moment? The bending moment will be equal to this force, that is W, into this. Sorry. This will be W. The shear force will be W at each and every cross section of from the point of loading till the end point. And the bending moment will be equal to W into X. Okay. W into X. So W into X, so X is starting from this point and going up to here. So for, if you write this point as A, this end point, and this point, the point of load, application of load, as B. So bending moment at A, that is at B, suppose at B, will be equal to 0. Why? Because we are considering the X from this point and X at B is equal to 0. So the bending moment will be equal to 0. And if we talk about the bending moment at A, the bending moment at A will be equal to W into L by 2. That is maximum, because the X will be maximum at the fixed end. Okay, so the answer for this one is absolutely correct, all of you who have given me the answer as option C. Okay. At center, if SSB, if it is a simply supported beam, I have one question of that case. Okay, let me come to that question, Rahul. Okay, then we will consider that. So till now you can see that this is the case of a point load, and from the point load, the variation of shear force, the shear force is a constant and the bending moment is of one order, that it is a linearly dependent on X. Okay, this we will discuss in a greater detail when we will be discussing, or when we will come to the class of SFD and BMD. Okay, so till then note this answer, option C is correct. And now moving on to the next problem, C. Now Rahul, your question, that question which you are talking about, the simply supported beam has come. Now you can see this. Okay. See this question. Maximum deflection is at free end and maximum shear stress is at the fixed end. Yes, absolutely correct. Pankaj Yadav, Ramesh Kumar Singh, you both are absolutely correct. Okay, now read this question. A simply supported beam of 1 meter length is subjected to a uniformly distributed load of 0.4 Newton per meter. The maximum bending moment occurring in the beam is. Okay, so this is a case of a simply supported beam. Let me draw a simply supported beam. Having a UDL. Having a UDL, it says it's having a UDL. Okay, so let me draw a UDL out here. This is the UDL. Having the intensity as 0.4 Newton per meter and this total length is 1 meter. Okay, this is the span basically what we call 1 meter. Okay, so yes, so for this case, the bending moment is maximum at the center. The bending moment is maximum at center. That is given by WL square by 8. Okay, WL square by 8, where this W is the load intensity. Okay, that is the UDL. So just put the values, W as 0.4, length that is the span as 1. So 1 square divided by 8. So this is 0.4 divided by 8, which you will get as 0.05. So the answer for this one is 0.05. That is the answer as C. C is the right answer for this one. Okay, C is the right answer for this one. About each and every case, that is the cantilever beam, every case of cantilever beam, that is the point load, the UDL, the UVL, uniformly distributed load, uniformly varying load, the cases of distributed and varying moments for the simply supported beam, cantilever beam, that all we will discuss in a very greater detail when we will meet on 25th, that is in the class of SFD and BMD. This class is just for making you understand what are the level of questions that are asked in the examinations of SSC and RRB JE. Please don't mind asking this question during JE class. Okay, move on. Now the question is from cylindrical shells, that is thin cylindrical shells or the thin pressure vessels. The answer, give me the answer for this one. That is, a circumferential stress in a thin cylindrical shell due to internal fluid pressure is given by. We are talking about the circumferential stress. Please note down that circumferential stress. Okay, first of all, you give me the answers. Shashi Kumar God, I don't know which timing you are asking me about. Please repeat your question. At what time? If you are asking me about the class of timing of class on 25th, the timing will be same, that is 6 p.m. GATE 2020 study plan will start really soon. The GATE result have already out, okay, 2 days back. Okay, so we will be coming up with the course very soon. Okay. So give me the answer for this one. Circumferential stress in a thin cylindrical shell due to internal fluid pressure is given by stress, that is sigma circumferential, or that is also known by one another name, that is sigma hoop, that is the hoop stress. Okay, this is given by P di upon 2t. If it is not mentioned di, that is obvious that it is the internal diameter. Okay, and t is the thickness, and this P is the pressure. This P is the pressure. Okay, so you get the answer clearly written as PD by 2t. And there is one more stress that is not asked in this question, but you must all know. That is a longitudinal stress, that is just hoop by 2, that is half of hoop, that is nothing but PDI by 4T. Okay, these are the two kinds of stresses that are present in the case of thin cylindrical pressure vessels. Okay, now I am asking you one condition. Now I ask you one condition from this same topic of pressure vessels. This is not the part of the questions that are given here. I just want to have a look at your concepts. Okay. Pressure vessels, if we talk about the pressure vessels, they are of two types, that is thin and thick. Thin and thick, two kinds of pressure vessels. So I want to know what is the value of d by t, that is the diameter, that is the internal diameter upon thickness. What is the value? Can you give me, any one of you can give me the approximate value of d by t, which differentiates or classifies the pressure vessels as either thin or thick? Any one of you can. Hurry up. This is just a part of concept. That is just the starting of the topic of pressure vessels. I am just asking you a question. As the question has come from pressure vessel, you must also know this thing also. Okay. That is the d by t ratio. That is not the slenderness ratio. The slenderness ratio comes in the case of buckling of columns. Okay. Yes. D by t. Yes. 20 or 15. Sometimes in some books it is written as 15 as well. Okay. If it is less than, not 10. Not 10, it's 20, it's 20. Okay, it's either 15 or 20, not 10. Okay, yes. If it is less than 20, that means it's a thick. Yes. If it's less than 20, it means it's a thick, and if it's greater than 20, that it means it's a thin. Okay. Yes. Less than 20 means it's thick. Greater than 20, it means that is thick, thin. Okay. And it's a d by t ratio. As the d by t ratio increases, that means either the thickness is decreasing. So thickness is decreasing, that means it's becoming a thin shell. GradeUp पर जो lecture की series थी वो क्यों disable कर दी गई है? The GradeUp the series has not been disabled. It is available for you, for everyone on the app. It is still available, but it will be available till only 31st of March. That is the duration of that course. Okay, that is the ending date of that course. That will be available till 31st of March. After that, you won't be able to see that, okay, or to learn from that. Okay, so now moving on to the next question. This question says the definition of Poisson ratio. Okay, give me the answer for this one. How the Poisson ratio is defined. Okay. So as you can see from these questions, these are the previous year questions which I have taken. Okay, these are not the questions that have been made by our experts or anyone else. These are the questions that which are available, which are given in the, or which have come in the examinations, the actual examinations of SSC and RRB JE. Okay, so you can see the level of questions is not tough at all. The level of questions is not tough. You just have to have an idea, or you just have to have the vast coverage of the syllabus. Okay, you first of all you have to understand that which topics are important, which topics we need to learn, and in how much greater detail or depth. That is just only what you need to understand. Then otherwise these examinations are not that tough. Okay, if you are a diploma holder, then also it's not tough, and even if you are a BTech graduate who have sometimes given a GATE examination, so these examinations are not tough. You just need to have a foolproof strategy, a foolproof planning, and then you can easily crack those examinations. Okay, and if you have any problem, so for all of you who are feeling a little bit low due to some reason or the other, okay, so if some of you have given the GATE examination, you didn't get the marks or the ranks according to your expectation, don't worry. Railway has given you this very good strategy, very good option. I need to say very good option for you, or very good, this is a very good chance for you to get a job a job in the railway sector. Okay, that is the biggest employment sector, not only in India but also in the world. So that has given you a great chance if to become a JE in the railways. Okay, so just focus and get that exam clear. And for all of you, we are bringing a paid course that, as I have already told you, the paid course will be live very soon after the Holi. And that's opportunity. Yes, that is the word I was missing. Yes, yes. Thank you, Abhishek. It's me, Abhishek. Yes, great, Abhishek, for telling me that. Yes, I need your lecture series for PSC as my optional subject is mechanical. Okay, it is showing that it was till 15th March. No, it is now. It has now the date has been extended till 31st of March, but after 31st of March that will not be available. Okay, so now coming back to the question, Poisson's ratio. The Poisson's ratio is defined as, means it is written as mu. Sometimes it is written as mu, or somewhere you will also see that written in the form of 1 by m. Okay, 1 by m. Sorry for the disturbance, but please tell me the way to avail all the lectures. See, all the lectures are available on the app till 31st of March. Till 31st of March, that is the free courses available. You can watch them n number of times. But after 31st of March, those classes or those course will not be available for anyone. Okay, that is the duration of the class that we have already told you from very beginning. So 31st of March till 31st of March, you can watch them videos n number of times. Okay, no problem for disturbing. Okay, so mu by m is lateral strain, the ratio of lateral strain upon longitudinal strain. That is a simple formula which you need to understand. Okay, and lateral upon longitudinal. Okay, if I rub this part also, then it's also not any problem, because that you understand it's about the strain. So lateral strain upon longitudinal strain. Okay, and we introduce a minus term here because the lateral and longitudinal strains have the opposite nature. If one is positive, the other one will be negative. Okay, so yes, one is positive, other will be negative. So to make this Poisson ratio a positive quantity, we come with a negative sign. Okay, and one more thing you can see that this is one question, that what is Poisson ratio. If sometimes a question is asked, what is the unit of Poisson ratio? You can see that it is strain by strain. Strain in itself is a dimensionless quantity, and moreover this mu is stress, strain by strain. Okay, so the ratio of true strains, so that's why it is a unitless, or basically you can say dimensionless. This is a unitless or a dimensional constraint. Why not negative of lateral strain? That is, we have introduced a sign here. Okay, because if this is positive, this will be negative. If this is negative, this will be positive. So this ratio will become negative altogether. Okay, if this ratio becomes negative altogether, so to introduce that, to bring this, to make this value mu as positive, that is minus of lateral strain by longitudinal strain. Okay, now see the next problem. This says a volumetric strain it says the volumetric strain of a rectangular body subjected to an axial force in term of the linear strain E, and the Poisson ratio mu is equal to. Okay, give the, see, for this question I will be drawing a diagram for you to explain in a greater detail, and if you follow this kind of a strategy, the questions like this is not a problem. Okay, the concept of stress strain, the Poisson ratio and everything will be clear through this question. Okay, see, just see this problem. What I am going to do here is, see this is the x direction, the y direction and the z direction. Okay, x, y and z. Okay, no, we should not use the value of, that is what the definition only says, minus of lateral upon longitudinal. Okay, so if we take, these are the values of x, y and z. This is x, that is px. Suppose the load that is acting in the px direction, this is py and this is pz. Okay, so now what I do one thing. See, These are the three loads that are acting in the three mutually perpendicular directions. And here I write the directions. That is the x direction, the y direction, and the z direction. Okay. So if you see this, the load x, that is the px load in the x direction, will cause a longitudinal stress or the longitudinal strain. Okay. And then it is simply given by the strain. These are the strains which I am talking about. Okay. These are the strains in every direction. These are what I am talking in the x, y, and z direction. These are the strains. Okay. So this can be written as px upon e. For this one it is a longitudinal. For others, this px in the y and z direction will be a lateral strain. So that is minus mu into px by e and minus mu into px by e. Okay. Similarly, for the other cases, the py will be the longitudinal for y. So this will be simply py by e. This is minus mu into py by e, and this is minus mu into py by e. Okay. And for this one, the z direction, this will be a longitudinal strain, that will be pz by e, and for these two it will be a lateral, so minus of mu into pz by e and minus of mu into pz by e. Now we see for each and every directions what are the stresses, what are the strains that are produced. If we talk about the x direction, we get that is px by e minus mu times of py by e minus mu times of pz by e. Okay. Okay, about the test series, some of you are complaining. I haven't seen it personally, but it's my request that if you are facing any problems, okay, I will communicate from my side also to the concerned department to have a look into this. And you can also contact at our helpline number or the website, that also the email ID, that is help@gradeup.co. You can contact at that, okay, and raise your concern out there. And personally also I will be communicating this concern to the concerned department. Okay, so don't worry about that. So okay, about if we talk about this, so this will become px by e minus mu times of py by e plus pz by e. Okay, for x. For y and z also similarly it will become somewhat like this. Okay, for somewhat like this it will become py by e minus mu times of px by e plus pz by e. Okay, and for the z direction also if you talk about, this will become pz by e minus mu times px minus pz, px, y, z, yes, y by e. Okay, so this is basically the value of strain in x direction, strain in y direction, and strain in z direction. Okay, and you know the volumetric strain. What is the volumetric strain given by? The volumetric strain is given by epsilon x plus epsilon y plus epsilon z. Okay, just adding these three terms. So we get the value of volumetric strain as, if we add these three terms, we get px plus py plus pz by e into 1 minus 2 mu. We get this term. Okay, so let me rub this one and write it here. Volumetric strain is equal to px plus py plus pz divided by e into 1 minus 2 mu. Okay. This one. So this is what we are talking about in this question as E, that is the lateral strain. Okay, in terms of the linear strain, the linear strain. So the answer for this one is a E into 1 minus 2 mu. The answer was an easy case. The answer finding is not a big case. Okay. Okay. So this is the answer for this question. That is option number A. But what I have done or what I have shown you so far is that how to understand the concept. of the stress strain, elastic constants, that is the Poisson ratio, how to analyze by the three kinds of strains. Okay, so this is the level of study that we are going to have in the paid course. This is just a preview of that. Okay, I'm not boasting anyone, I'm not praising the anything that I am a good teacher or whatever. I just want to make the things clear for you. Okay, this is my job, or this is my work towards you all, okay, who are having faith upon us, who are giving us your time. You all are giving us your time, precious time, learning from GradeUp. Okay, so this is the level of learning that we are going to have in the paid course, because in these sessions the time is also limited, so we are not able to cover everything in a greater detail. Okay, we are not able to cover everything in a greater detail, but in the paid course we will be having an ample amount of time for each and every topic, each and every subject, and on that we will be having greater details on each and every question. Okay, paid course cost is, I told you, for only CBT 2, that is only CBT 2 mechanical, it will be 8,000, around 8,000. Okay, the prices, that will be the first come first serve basis, that is the early bird offer, what we call it. Okay, that is the discounted price, will be around 8,000. Okay, no. And for the CBT 2 plus 1, that is combo pack for CBT 2 and 1, the prices will be around 12,000. Okay. Free classes we won't be able to continue. We will be continuing them, but we won't be able to cover each and every topic or each and every part of the syllabus. Okay, that's why we are saying we are bringing you a paid course. Okay, so that is really beneficial at just a minimal cost of 8,000 or 12,000 for both the CBT 1 and CBT 2, and that is a very nominal cost. Okay, that is very a nominal cost. I don't find that it's a very high cost. Okay, so now give me the answer for this one. In a composite bar in series connection, the resultant deformation produced will be. What is the resultant deformation? The resultant deformation is simply, you know, that is the case of bar in series. The resultant deformation is the sum of individual deformations. Okay, there is nothing much to explain in this one. Okay, deformation will be the sum, and this is the case of a series connection. Okay, and if I move forward, if I talk about the parallel connection, for the parallel connection, the case is that the deformations are equal. The deformations are equal. Okay, and in the series case, the deformations are the sum. So the correct answer for this one is option A. Free lectures, these free lectures, or you are talking about, or about the course, that is the GATE course which we did last year. If you are talking about these videos that we are running on the YouTube, they will remain forever on the YouTube channel, no worries about that. But for the course, that will be ending soon. Okay, by the end of this month, that course for GATE will end soon. Okay, yes. Now moving on to the next question. In a homogeneous isotropic elastic material, the modulus of elasticity E in terms of G and K is equal to. Okay, E in terms of G and K. There are three modulus of elasticity, basically three elastic constants. That is elasticity modulus of elasticity as E, shear modulus as G, and bulk modulus as K. Okay, so we have the relation as E equal to 2G 1 plus mu, E equal to 3K 1 minus 2 mu. Okay, so you have to find out the relation of E in terms of K and G. So what you have to do, simply find out the value of mu from this equation. Okay, that you will get as E upon 2G. From this first equation, if you talk about, from this first equation, find out the value of mu, that is mu is equal to E upon 2G minus 1. This is the value of mu from this, and substitute this value of mu into second equation. That's it. That's what you have to do. You will get the answer as E equal to 9 kg upon 3K plus G. That is the option given in A. Okay. Yes, all of you are correct. This is basically a general expression also, which you all should remember by heart, because that will save your time in examination. because in the examination when you have to solve number of problems, then doing these kinds of derivations become a bit tough. So you can just remember this expression, this and this expression you already know, you can remember this expression as well. This will save your time. Okay, now moving on to the next problem. It says a long structural member subjected to an axial compressive force is called. Okay, please read the question carefully. It says a long structural member subjected to axial compressive force is called. Okay, you AIM, UP, PSC, you are doing a request. Okay, I will forward this request as well to the concerned department and let's see what their final decision on this is. Okay, you don't worry. Till then, you don't worry about the dates. Still, there are good number of days left till 31st of March as well, if that course gets over till 31st of March. Okay, don't worry. You read whatever you want from those lectures. Okay, and I will give your concern, I will raise your concern in front of the concerned department and let's have a look what they say on to this one. Okay, so now give me the answer for this one. What is this? Column. Most of you are saying the answer as column. And strut. Some of you are giving me the answer as a strut as well. But the answer for this one is correct, is a strut. Okay, why? Because if you carefully read the definition of columns and strut, it says this, what is given, the statement which is what is written here is that a long structural member subjected to an axial compressive force is called. This is the clear definition of strut, first of all. If it would have been written a long structural vertical member, for the column, for the strut to be a column, this vertical condition should be there. Okay, Abhishek and all those who have a confusion in this one. Okay, all those who have a confusion in this one, please carefully look into this. If it simply says a long structural member subjected to an axial compressive force, that is a strut. Okay, no, strut is not a, strut is a short and long, it can be both. Okay, don't worry about that. But this vertical word must as well be there for the strut to be a column. Okay, so that's why it says that every column is a strut. Every column is a strut, but every strut is not a column. Vertical member is column, yes, that is what I am saying. Okay, this vertical member is a column. Okay, beam and frame. Beam is just a kind of what we see, a beam that is subjected to transverse loading. This is basically the definition of a beam, that a structural member subjected to transverse loading. That is the case of a beam. Okay, it can be subjected to a longitudinal loading as well, but if we talk about a definition of beam, it says a beam is that is subjected to a transverse loading. Okay, now moving on. Next question. The materials which exhibit the same elastic properties in all the directions are called. What are those materials called which exhibit the same material properties in each and every direction? In each and every direction which have the same properties. Okay, the material which exhibit the same elastic properties. See, if this is a point and in these all the directions, if the elastic properties are same, that is, the elastic properties are independent of the direction. So what that kind of material is same, is said. What that kind of material is said? In all the directions. Okay, please note that, in all the directions. I am getting the mixed answers again, A and C. There is a confusion between homogeneous and isotropic. Okay, the correct answer for this one is, I am saying the correct answer for this one is option C. That it is isotropic material in which the properties of the material are independent of the direction. Now what is then homogeneous? The question comes now, what is homogeneous? See, if this is 1.1, if this is another point in the same material as 2, and at this point, if the directions, the properties are like this, suppose this is any material what we are talking about, okay, suppose the arbitrary shape of a material, then there are 2 points into this, one is this and one is this, okay, and in this there are this kind of elastic constants, like in this direction it is E1 at both these points, at this direction it is E2, in this direction the vertical direction it is E3, and in this direction it is E4. So this kind of material, if you see at every point in all the directions, the elastic constants or the elastic properties are different. So that is not a, this is a non-isotropic material first of all, okay. Now this is a non-isotropic material. Now at each and every point, if you see at each and every point in the same direction, the elastic constants have the same values, the elastic properties or the elastic constants have the same values in same direction at every other point, at every point, okay. So this is the material is a homogeneous material. Now this material becomes a homogeneous material. This becomes a homogeneous material, okay. Homogeneous means values same at every point in a given direction, and for the isotropic means values same in all the directions in the given point. That is just the difference between the homogeneous and isotropic, okay. So I hope you get this concept clear. Now you won't be doing any mistakes. Now what's the confusion, Abhishek? Ask. In this question, if you have any confusion, what's the problem? Ask fast. What's the what's the doubt you have or any one of you have in this question? Please ask. I am saying that if there is a material, if you take any point in a material, if you take any point in a material and as at that point in all the directions, if you see isentropic, no, it's not isentropic, it's isotropic. Isentropic is a process that is in the thermodynamics process that we have understood, we have read, okay. Now see, any one of you have the confusion, the doubt in this, please have a look at this. I am again explaining it once again. Yes, I am doing that. Please look here. Take a single point. In that single point, if the elastic properties are same in all the direction, if at a single point the elastic properties are same in all the directions, that means the elastic properties are not depending upon direction. Not depending upon direction means it's a isotropic material. Like I said, if this is a point in each and every direction the elastic properties are same, that means the elastic properties are not direction dependent. That means this is a isotropic material. This is a isotropic material. Okay? Then, for the homogeneity, to check the homogeneity, what you have to do, take 2 points. Take at least 2 points, and in those 2 points, see the value, check the value of elastic constants in a particular direction. If you see, in this point, at this point, we are considering the values of elastic constants in a particular direction. Like we have seen in the horizontal direction it is E1, in the vertical direction it is E3, in this direction it is E4, and in this direction it is E2. That means the values in a particular direction, the values in a particular direction at each and every point within this material is same. That means it's a homogeneous material. Okay? So I will give you a hint to remember this. Isotropic means the properties are direction independent. Just remember this. That means if the properties are not depending upon direction, that means it's the properties are same in all the direction, that means it's a isotropic material. Okay, and if for the homogeneous means they are not depending upon the points. Okay, they are point independent. Means at each and every point in a particular direction, the values of elastic properties or the elastic constants are same. Okay? Yes. Now I hope everyone's doubt is clear in this one. Okay? Okay. Okay. Now moving on. Next question. If a part is constrained to move and heated, it will develop which kind of stress? Principal stress, tensile stress, compressive stress, or the shear stress? Give me the answer for this one. If a part is constrained to move and heated, it will develop which stress? C. I have got the first answer from Abhishek. It's C. Now give me other answers fast. We are already 1+ hour into this session. I don't want to extend this session too long. Please hurry up. Not B. It's a compressive stress. Okay, why compressive stress? I will explain it to you. Suppose this is a member. Okay. If it is constrained from all the directions, let us say, if it is heated, okay, if it is heated and it has a alpha, alpha is the expansion coefficient, okay, and if it is delta T, that is a positive, that means it's heated, okay, and if it has this value also as also positive, that is the coefficient of thermal expansion or the coefficient of linear thermal expansion. Okay, if this is also positive, this is also positive. So what will happen when you heat this material? This will try to expand. This will try to expand in all the directions. Okay, and when it will try to expand, what will happen? Because these these supports or these reactions are rigid, they won't allow this component or this body to expand. Okay, this won't allow the body to expand. So if the body will not be able to expand, so from all the directions there will be the reactions that will be acting into towards the inside, towards the inner side of this body. And due to these reactions, there will be the compressive stress that will be developed into this body. Okay. When the bar is cooled, basically if the bar is cooled, that means if it has a positive coefficient of thermal expansion, that means when the bar is heated, it becomes hot, it expands. When the bar is cool, it contracts. When it contracts, then the supports reactions will try to expand it from all the sides. Okay, because these are rigid. They are not going to leave the material. Okay, they leave the component. So they are trying to stretch it from all the directions. And when they will try to stretch it in all the directions, then surely it will be a tensile stress. Okay, so please have a look at this, that whenever the temperature is positive, that is delta T is positive and alpha is also positive. That means the material is like that. On increasing the temperature, if the material expands, then it will be a compressive stress developed into this material. This will be a compressive stress. Okay, and when the delta T is negative, but the alpha value is still positive, that is the material is having the positive constant, positive coefficient of thermal expansion. That means when the temperature will decrease, the body will contract. In that case, it will be the tensile stress that will be developed in the body. Okay. Okay. Now moving on to the next problem, the 15th one. It says, for steel, the ultimate strength in shear as compared to in tension is nearly. What is the ratio of this? What is the ratio of these two? It talks about the ultimate strength in shear as compared to in tension. That is SUT, ultimate strength in tension, and SYS, that is the ultimate, that is the shear stress. Okay, shear. So compared to this, what is this one? Basically it is asking you the ratio for SYS by SUT. This is nearly what? Same, half, 1/3, 2/3. You don't have to think about this question into that much time. You don't have to take that much time. This is a simple one. The answer for this one is half. That is 1/2. SUT, SYS by SUT, or sometimes it is SYT also written. That is the yield stress in tension. The value for the ratio for this one for both is half or 0.5. Okay. A is not the answer. B is the correct answer for this one. B. Okay. Now, moving on to the 16th problem, it says the deformation per unit length in the direction of force is known as. Deformation per unit length in the direction of loading. Please find that word, in the direction of loading. Deformation per unit length in the direction of force. If this is the body, this is the direction of force. Okay, this is L. Due to this force, if this body gets expanded by this, that is delta L. So, delta L by L is known as what? This is the question. Delta L by L is known as what? This is known as linear strain, absolutely correct. This is again a very simple problem. I won't be taking too much of your time into this session. Okay, we are already 75 minutes around into this session. I won't be taking a lot of time. The answer for this one is linear strain. Okay, if it would have been asked in the direction that is transverse to the loading, that means in this direction, if this is D and on when this material increases, this decreases to this much, that this much is basically the delta D. Okay, delta D with the diameter which have decreased. So this delta D by D would have been lateral strain. This would have been the lateral strain, and the ratio of this lateral strain by this longitudinal strain is nothing but the Poisson ratio that we have already discussed. Okay, yes, lateral strain. Okay, now moving on further, it says the validity of Hookes law. The Hookes law holds good up to which point? The yield point, the limit of proportionality, the breaking point, or the elastic limit. We are into the 17th question now. Give me the answer for this one. Hookes law holds good up to which point? Hookes law. That is not the clear strain, that is the linear strain or the lateral strain. Okay. Hookes law holds good up to which point? Yield point, limit of proportionality, yes. 17, the answer for this one is, please everyone remember this, that Hookes law is valid up to the limit of proportionality. That is, B is the right answer for this one. Okay, in a stress strain curve, if you see something like this is the elastic point or the elastic limit, then this is the proportionality limit after which the yielding starts. Okay, this is suppose the proportionality and this is the elastic. Okay, so the Hookes law is valid. Hookes law basically defines that stress is directly proportional to the strain. This is stress, this is strain. This is stress strain curve. If you see into this stress strain curve, this Hookes law says that stress is directly proportional to strain. Okay, and this is valid up to the elastic limit. This is valid up to the proportionality limit. Sorry, this is valid up to the proportionality limit, not up to the elastic limit. Okay, B is the right answer. It says, I absolutely agree with you, Surya Bharat. You says that Hookes law states that within elastic limit, stress is directly proportional to strain. That's absolutely correct. But please mind my words as well. I am as well saying something to you, that the limit of proportionality is that point up to which the Hookes law is valid. Okay. Stress is directly proportional to strain. Okay. Now, we are into the second last problem. Please give me the answer for this one. Resilience of a material is important when it is subjected to. Resilience. Resilience. Yes, elastic point is below the proportionality limit. Oh, yes, yes, absolutely, you are right. Yes, you are right. Elastic limit, yes. Sorry, I made that wrong. Okay, wait. Yes, absolutely, you are absolutely correct. I am really sorry for that. Please, yes. This is the proportionality limit and this is the elastic limit. Yes. Above the point above which the yielding starts. Above the point above which the yielding starts, that is the elastic limit. And this is the proportionality limit up to which the Hookes law followed. That is, stress is directly proportional to strain. Yes. I am making this correction. Please note into the last problem. It says that Hookes law holds good up to. Hookes law holds good up to the proportionality limit. This is the proportionality limit that is below the elastic limit. Yes. Thank you. Thank you for anyone who has given me this explanation. Yes, absolutely correct. Yes. Now the answer for this one. Resilience of a material is important when it is subjected to combined loading, fatigue, thermal stress or shock loading. Yes. So both the resilience and the concept of toughness, they both are important when the material is subjected to impact loading, or in other words it is also called as shock loading. Impact or shock loading. When the material is subjected to impact or shock loading, then these concepts of resilience and toughness are important. Okay. Shock loading, yes. Now, the last problem, the property of a material which enables it to resist fracture due to high impact loads is. Shock or impact load both are same. Okay, impact loading or shock loading both are same. Okay. Yes, give me the answer for this one. The property of material which enables it to resist fracture due to high impact loads is known as. We are talking about the fracture. Okay, we are talking about the fracture. Anyone the answer for this one? The last problem of the day. Last problem of the day. The property of a material which enables it to resist the fracture due to impact loads, high impact loads. That is the fracture we are talking about. Yes, toughness, not 19th. The correct answer is toughness. Okay. Okay. So just a little bit of concept. This is a kind of a somewhat a stress strain curve. Okay. So this is the elastic limit. If we talk about the energy that is stored or the strain energy that is stored within the elastic limit, whatever is stored, that is resilience. Okay, what is resilience? This is resilience. The energy that is absorbed in the material within the elastic limit is resilience. Okay. Up to elastic limit if you talk about, that is proof resilience. The maximum value of strain energy that is absorbed by the material inside the elastic limit, up to the elastic limit, or the maximum in the elastic region, that is proof resilience. Okay. Any strain energy that is absorbed within the system or within the material, within the component, within the elastic region, it is known as resilience. The maximum within the elastic region or the up to the elastic limit is known as proof resilience. And the total, if you talk about till the fracture, total if you talk about up to fracture or total, up to fracture it can be written or total it can be written, that is known as toughness. Okay, These are the difference. Strain energy can be anything. Strain energy is a energy that is absorbed by the body. Okay. That is half sigma into mu. This is the strain energy, any. But within elastic limit it is known as resilience. Up to elastic limit it is known as proof resilience. And up to total or fracture it is known as toughness. These are the differences. Yes. Maximum strain energy that is stored within the elastic limit is the proof resilience. Yes. Absolutely correct. Then there are two more terms, that is the modulus of resilience and modulus of toughness. That is nothing but the toughness per unit volume and proof resilience per unit volume, that are known as modulus of resilience and modulus of toughness. कल क्लास नहीं होगा मनीष कुमार, the class will be day after tomorrow. Okay. The schedule has also been given in the description box. Okay. Endurance means the maximum value of stress that a material can withstand in the case of a cyclic loading. Okay, that we will discuss in the case of design against dynamic loads in the subject of machine design. Difference between strain energy and resilience I have told you. Strain energy and difference between strain energy and strain energy and resilience I have already told you. Strain energy is this, that is half into sigma into epsilon, that is half stress into strain. Okay, within elastic limit if you find it out, that is known as resilience. Up to elastic limit the maximum value is known as proof resilience, and up to total, that is the total of fracture, that is known as toughness. Okay, yes. So thank you all for being a part of this session. It was nice interacting to all of you. Okay, kal class nahi hogi everyone, tomorrow there will be no class, and the class will be on 22nd now, day after tomorrow. Okay, once again the paid course CBT1 plus CBT2, okay, and CBT2 mechanical, okay, course live soon after the Diwali, after Holi, sorry, after Holi. Okay, day after tomorrow the class will be on stress, strain and elastic constants. Okay, so I am just giving you a information that the paid course CBT1 and CBT2 paid course soon launch after Holi. Okay, and next class Gearup JE'19 SOM subject, SOM topic stress, strain, 22nd of March, day after tomorrow, 22nd March, day after, not 22nd March, 20th March, day after tomorrow at 6 p.m. Okay, so see you all in that class. Okay, till then, thank you, bye bye, take care, good night.